Bismillahirrahmanirrahim. Today I will solve the remaining numerical problems of first year chapter number 2, vectors and equilibrium. 10th numerical is a uniform plane AB of length 4 meter and weight 500 Newton is suspended by a vertical rope at each end. This is plank and it is suspended by two ropes A and B. The length of this plank is 4 meter and weight is 500 Newton. A girl of weight 300 Newton is standing at a distance of 1.2 meter from the end A. Here, from distance of 1.2 meter, this is a girl and its weight is 300 Newton and is standing from 1.2 meter from the end A. By taking moments about A, here let this is axis of rotation. Calculate the tension in the rope supporting the end B. Calculate the tension in this rope. Here, find the tension in the rope B. This is uniform, so anti-clockwise tug is equal to clockwise tug. This is known as principle of movement. And here, in anti-clockwise direction means in this is B. So force provided by B, and from axis of rotation its distance is 4 meter. So here anti-clockwise the torque is equal to, here is a girl at distance 1.2 and its weight is 300 Newton. Plus here this is center of gravity and its distance is 2 meter. And weight of the plank is 500 Newton. So 4 into FB is equal to 360 plus 1000 Newton. So 4 into FB is equal to 1360 Newton. So FB is equal to 1360 divided by 4. So FB is equal to 340 Newton. This is tension in this rope B. The 11th numerical problem is here. This is a door which we are looking from upside. This is axis of rotation and this distance is 1.8 meter. This is point B. The diagram shows the plan view of a door hanging at A. This is A. If a man applies a force F of 40 Newton at the end mark B, here if a man applies a force of 40 Newton, calculate the moment of the force about A. What is the minimum force? X that must be applied at C in order to stop the door from turning. To find torque is equal to force into moment R. So torque is equal to force. A man applies a force of 40 Newton and applies here. So from axis of rotation to the point of the action of the force, this distance is 1.8 meter. So torque is equal to 72 Newton. Here this is torque in anti-clockwise direction, and as anti-clockwise torque is equal to clockwise torque, so TA is equal to anti-clockwise torque is 72 Newton meter is equal to, here this is point C and this distance is 1.2 meter. What is the minimum force applied at point C in order to stop the door? The distance is 1.2 meter and we have to find the force applied at point C. So 72 divided by 1.2 is equal to FC, and Newton meter divided by meter. So here FC is equal to 0.2. Here FC is equal to 60 Newton. The minimum force applied at point C is that 60 Newton in order to stop the door from turning. Twelfth numerical is, consider a ladder weighing 200 Newton resting against a smooth wall such that it makes an angle of 60 degrees with the horizontal. Here this is frictionless wall, smooth wall, and this is ground. Here this is the ladder and it makes an angle of 60 degrees with the horizontal. Weight of the ladder is 200 Newton. Here wall applies, here a ladder, weight of the ladder acts on wall and wall reacts on the ladder. So this reaction is normal to the wall. So here this is normal reaction of the wall, and if the ladder slips, then the ladder will move in this direction, and friction is always opposite to the direction of motion, so friction will be in this direction, and this is normal force, normal reaction of ground. Find the reactions on the ladder due to the wall and ground. Here we have to find the resultant of these two vectors. So here this all length is L of the ladder. So and here this, let upper forces is equal to downward forces, Rg is equal to W, and W is 200 Newton. So it means that Rg is also equal to 200 Newton. Normal reaction of the ground is equal to 200 Newton. Now Rw, to find Rw, here components of the length. This is L sine 60. These are the alternating angles, that's why these are equal. And here, if the whole length is L, so this length will be half L divided by 2. So by drawing components of L divided by 2, this is L cos 60. So by turning moment at here, so Rw is L sine 60 into Rw is equal to L divided by 2 cos 60 into W. So here sin 60 is 0.866 into Rw is equal to cos 60 is 0.5 into weight is 200 and 200 divided by 2, so 0.866 into Rw is equal to 0.5 into 100. So Rw is equal to 50 divided by 0.866. So it is equal. So it implies that Rw is equal to 208 Newton. This is Rw and this is Rg, and we have to find reaction of these two forces. As Rw is this and it is equal to friction. So this is, and here this is Rg, which is in upper direction. This is one force and this is second, and we have to find this. This is Rg and this is Rw or F, and we have to find this R. So here we can use Pythagoras theorem, which is Rg whole square plus Rw whole square. So R is equal to square root and Rg whole square. Sorry, this is 57.74. R is equal to 200 square plus 57.74 whole square and square root. So R is equal to 208 Newton. This is the resultant of these two vectors.